We're going to practice stoichiometry. And with this lab, you're going to be also practicing stoichiometry when we're done. So with the lab, you get a chance to see how we actually use this stoichiometry we're going to practice doing in class. Okay? And if you don't remember from your studying, stoichiometry is spelled like this. I mean, you should know how to do that, spell it at this point from studying. Stoichiometry. The definition of stoichiometry can be stated in this way. It is the math and chemistry that requires that you have a balanced chemical equation. Now, in Unit 1 in this class, we learned to write conversion units from equality statements. In Unit 1, we learned to write conversion units from equality statements. We also learned to handle significant digits properly. We're going to be using that information in this unit. Okay? In Units 3 and 4, we learned to write and balance chemical formulas. Okay? Well, when we predict the products of a reaction, you have to know how to write and balance chemical formulas. So that information is going to be in this unit. And in Unit 5, we learn to predict the products of a reaction and to balance a chemical equation. We're going to use that information in this unit. We're going to take all of those things and move forward. We're going to use it in a big picture kind of way. Okay? So it's important for you to, in order for you to get a real grasp of what we're trying to do here, it's important that you kind of understand this foundational stuff and not lose sight of this big picture when we're doing the minutia, the detail stuff in the class. Okay? You got to kind of have two perspectives at the same time. Some people are really good at the detail stuff. Some people are really good at the big picture stuff. But in this unit, you get the most out of this unit if you can kind of keep a little bit of a view of both. Okay? So what we want to do is to not lose sight of what we're trying to, the big picture, and also don't forget about the detail stuff you got to take care of. Okay? All right. Now, we're going to get to the stoichiometry part shortly. We're going to start out with a little bit simpler stuff that helps you to remember about setting up conversions. Okay? So, we did a mole project on mole day, and from that mole project, you should know how many particles there are in a mole. There you go. Great. You should know that. You shouldn't have to relearn that. You should know that there are 6.02 times 10 to the 23rd particles of anything in one mole of that same thing. Okay? So these particles and this stuff in the mole must be the same thing. Okay? So if the particles or molecules of water, then there'll be moles of water on the other side. If the particles are electrons, there'll be moles of electrons over here. If the particles are formula units of table salt, then it's moles of table salt over here. Does that make sense to everybody? Okay. Now this is an equality statement. And you apply the same thing. When I say same thing, I'm talking about molecules of water and formula units of table salt and electrons. The same thing gets put over here on both sides of that equation. So it's particles of water molecules and moles of water molecules. Does that make sense? Whatever it is, this equality statement applies. So that if you're asked to convert from number of molecules to the number of moles, this is the equality statement you're going to use, just filling in the species there. Does that make sense? Let's see how it applies. Let's practice it a little bit, okay? So I mentioned water molecules. Let's use those. So if you have 2.73 times 10 to the 24th atoms of iron, how many moles will you have? Okay? So what's your starting amount here? The starting amount is 2.73 times 10 to the 24th. That's 2, 7, 3, and 22 zeros. Okay? So you cannot leave off this. The amount includes this. The times 10 to the 24th. And it's not just a number. You have to tell me what the number applies to. Okay? So you have to tell me that it's 2.73 times 10 to the 24th atoms, and even that's not enough because you got to tell me what kind of atoms of iron. Does that make sense? Anthony, what do we do with our starting amounts? You remember from Unit 1? Anybody remember what to do with those? Okay, that's kind of reminding you from Unit 1, but let's in Unit 1, you always put your starting amounts over 1. Now you have to be able to interpret the problem to figure out what the starting amount is. And that was what a lot of you struggle with in Unit 1. Which one of those numbers is the starting amount? It tells you if you have this many atoms, that's a starting amount. Okay? So we're going to write 2.73 times 10 to the 24th atoms of iron. Well, I'm going to use the symbol because that's a lot less writing, isn't it?
Sure.
There you go. Over 1. Okay. If I want to convert from one unit of measurement to another, if I want to convert from one unit of measurement to another without changing the species, I want to convert from one unit of measurement to another without changing the species, I have to have an equality statement. Well, atoms of iron is a different measurement unit than moles of iron. So I need an equality statement. Here's where we get the equality statement from, right here. Particles can be atoms, molecules, electrons, ions, polyatomic ions, okay? Can be any kind of particle. That's a big picture idea. Not just words on the paper, but what do the words mean and applying it. Okay? Particles can mean atoms, electrons, ions, polyatomic ions. Dorman High School students. Since we're talking about atoms, can atoms be particles? Yes, I just said so. Atoms can be particles. So we're going to say 6.02 times 10 to the 23rd atoms. There's our particle. The thing here is what? Iron. Okay. Equals 1 mole. What's the same thing?
Particles.
Well, no. The particles is this. Moles is here. What's the same thing I'm going to plug in there? Iron. Okay, you see that? You have to apply particles and moles to the same thing. So I'm applying iron as the thing on this here. Okay? Alright, that's an equality statement. We build a conversion unit from an equality statement. We build a conversion unit from an equality statement. Well, the way we build a conversion unit is this. We look at the previous step in the problem and match the units and species with the side of the equality statement that it's like. Okay? So which side of the equality statement matches these units and species? this side here. So this number with these units and species are going to go on the bottom of our conversion unit. Exactly. 6.02 times 10 to the 23 atoms of iron goes on the bottom. The other side of the equality statement then can go on the top. Alright, now for anybody who likes to know why we do that, if you put something, two things that are equal on top and bottom in a fraction, two things that are equal on top and bottom of a fraction, that equals 1. Right? Okay? If it equals 1, then we're not going to change the amount of our starting stuff. We're going to change how it's measured. Does that make sense? Now that we build our conversion unit, we're ready to cancel units and species. Okay? If we've set it up properly, if you have set it up properly, you should be able to cancel anything that's exactly alike on the top and bottom of adjacent fractions. Okay? So atoms are on the top here and atoms on the bottom here. Those can cancel. You should be able to cancel species that are the same on the top and bottom and adjacent fractions, or in the same problem, really. So iron can cancel. So now we're ready to do the math. Okay? Yeah, you're in that drawer right there. Okay? Alright, so this is where you're going to need your calculator. Now, if you have a scientific calculator, this is going to be a lot easier for you. And if you have a graphing calculator, it's going to be a whole lot easier than that. Okay? But you have to learn to use your calculator. You have to learn to use your calculator. If you don't practice with it, you're not going to be able to do this on a test. Okay? So use every opportunity to practice. Anytime I'm doing math on the board or on the overhead projector, you should be practicing with me. This is really, really important, and it's getting down to brass tacks where the calculations get complex enough that if you don't practice, you cannot expect to get a right answer on a test. Okay? Now, these are two different operations here. You've got a mathematical operation here, 10 to the 24th. You've got a mathematical operation here, 2.73 times this, and then you have another mathematical operation where you take this number and divide by that, which is also two mathematical operations there. So, if you don't do it properly in your calculator, it's not going to give you a correct answer. Okay? So let's talk about how you can put this in your calculator. Just in let me do the math first, and then I'll show you how to do it in your calculator. Okay? I don't want to get too far away from what we're actually doing. So I'm going to do this math, then I'll show you how to do it. So I'm going to sort of put my answer down here. Okay? Okay, I got 4.53 4883721. And the units we have left are moles. Now this is what's really neat about this process. What is the problem asking you for? How many moles? Well, that's what we have left, isn't it? Okay? So we need to round this off now. So we match the number of significant digits with the measured or calculated number that has the least digits. That's the rule for multiplication and division. Match the measured or calculated number with the least digits. Okay, that's what we need to do in our final answer. There's 3 digits here and 3 digits here. So we want 3 digits in our final answer. This 1 and this 1, neither one of those are measured or calculated numbers. Okay, they're counting numbers, so we don't use those. Only the measured or calculated numbers. So we're going to underline everything after the first 3 digits. 1, 2, 3. I need to have my units and species. This is moles of iron. To round it off, have to have an arrow to show they were rounding off. And 4.53 moles of Fe is the final answer. Okay?